The Big Bang Theory is our best explanation for how the universe began. It tells the story of an unimaginably tiny point, smaller than an atom, containing everything that is. This point, incredibly hot and dense, suddenly expanded outwards. This event, about 13.8 billion years ago, marked the birth of space and time as we know them. The Big Bang Theory isn't about an explosion in pre-existing space, it describes the expansion of space itself. Imagine a balloon with dots drawn on it. As you inflate the balloon, the dots move apart. Similarly, galaxies are moving away from each other as the universe expands. The Big Bang Theory elegantly explains this observation. The Big Bang Theory is a cornerstone of modern cosmology. It's not just an interesting idea. This theory is supported by a wealth of observational evidence. This evidence allows us to trace the evolution of the universe from its earliest moments to the present day. At the very beginning, the entire universe was compressed into an infinitely small, infinitely dense point called a singularity. This singularity represents a point where our current understanding of physics breaks down. We don't have the tools yet to describe what happened within the singularity. Then, the universe underwent a period of rapid expansion, inflating faster than the speed of light. This period, known as cosmic inflation, lasted for just a tiny fraction of a second, but it had profound implications for the universe we see today. Inflation stretched out the fabric of space-time, smoothing out any initial irregularities. This explains why the universe appears remarkably uniform on the largest scales. This rapid expansion wasn't an explosion of matter into empty space, it was the expansion of space itself, carrying matter along with it. As the universe expanded, it cooled, and energy began to convert into matter and antimatter. These particles, born from the universe's energy, would eventually form the building blocks of everything we see. The Big Bang Theory isn't just a story we tell. It's supported by multiple lines of evidence that we observe in the universe today. These echoes of the Big Bang help us confirm the theory and refine our understanding of the early universe. One crucial piece of evidence is the cosmic microwave background radiation, or CMB. This faint afterglow of the Big Bang permeates all of space. It's like a baby picture of the universe, showing us what it looked like just 380,000 years after the Big Bang. Another key piece of evidence is the redshift of distant galaxies. As light travels through the expanding universe, its wavelength gets stretched. This stretching causes the light to shift towards the red end of the spectrum. By measuring the redshift of galaxies, we can determine their distance and confirm that they are indeed moving away from us. This observation provides strong support for an expanding universe. The universe evolves from fireball to galaxies. In the first few minutes after the Big Bang, the universe was an incredibly hot, dense soup of elementary particles. As the universe expanded and cooled, these particles began to combine, forming the first protons and neutrons. This period, known as Big Bang nucleosynthesis, is responsible for the abundance of light elements like hydrogen and helium that we observe in the universe today. Over hundreds of millions of years, gravity began to pull matter together, forming the first stars and galaxies. These early stars, much larger and hotter than our sun, lived short but brilliant lives, forging heavier elements in their cores. When these stars exploded as supernovae, they scattered these heavier elements into space, enriching the interstellar medium and providing the raw materials for planets and life. The universe we see today, filled with galaxies, stars, and planets, is a testament to the ongoing process of evolution that began with the Big Bang. From the simplest elements forged in the first few minutes to the complex structures we see today, the universe is a dynamic and ever-changing place. A universe in motion, expanding and accelerating. For a long time, cosmologists assumed that the expansion of the universe was slowing down due to gravity. However, in the late 1990s, observations of distant supernovae revealed something astonishing. The expansion of the universe is actually accelerating. This discovery, which earned the 2011 Nobel Prize in Physics, shook the foundations of cosmology. The culprit behind this accelerated expansion is thought to be dark energy, a mysterious force that makes up about 70% of the universe's total energy density. We don't yet understand the nature of dark energy, but its presence has profound implications for the fate of the universe. If dark energy continues to dominate, the universe will continue to expand forever. Galaxies will become increasingly isolated, and eventually, even the light from distant galaxies will be unable to reach us. The universe may end in a cold, dark state, a far cry from the fiery crucible of the Big Bang. The big questions: beginnings, ends, and our place. The Big Bang Theory raises profound philosophical and cosmological questions. What existed before the Big Bang? What is the ultimate fate of the universe? Are we alone in the cosmos? These questions have captivated philosophers and scientists for centuries, and the Big Bang Theory provides a framework for exploring them. The question of what, if anything, existed before the Big Bang is a particularly perplexing one. Some theories propose that our universe is just one in an infinite multiverse, each with its own set of physical laws and constants. Others suggest that the universe goes through cycles of expansion and contraction, with the Big Bang representing just the latest iteration in this cosmic dance. While we don't have definitive answers to these questions, the Big Bang Theory provides a starting point for our inquiries. By studying the universe around us and probing its deepest mysteries, we can gain a deeper understanding of our place in the cosmos and the grand tapestry of existence. The expanding universe of knowledge, the Big Bang's legacy. The Big Bang Theory has revolutionized our understanding of the universe. It provides a comprehensive framework for understanding the origin, evolution, and future of the cosmos, and it has spurred countless new avenues of research in cosmology, astrophysics, and particle physics. The theory's success lies not only in its ability to explain existing observations, but also in its predictive power. The discovery of the cosmic microwave background radiation, the confirmation of the universe's accelerated expansion, and the ongoing search for dark matter are just a few examples of how the Big Bang Theory has guided scientific inquiry and led to groundbreaking discoveries. As we continue to explore the universe with increasingly powerful telescopes and sophisticated instruments, we can anticipate even more exciting discoveries that will further refine our understanding of the Big Bang and its profound implications for our place in the cosmos. The universe of our knowledge, like the universe itself, is constantly expanding, driven by our insatiable curiosity and our desire to unravel the mysteries of existence.